Hello everyone, my name is Safura Sana from ISL Engineering College, pursuing IT final year, bearing roll number 18. Here I am going to give a short presentation of my project, that is machine learning based malicious application detection using Android. Some basics of machine learning. We know humans learn from their past experiences and machine follows the instruction given by human. But what if human can train the machines from the past data? Well, machines are used to complete the task in less consumption of time. That's called machine learning. The word malware came from malicious software. In similar words, it is a bad implementation of a good code is what malware. Before moving to the project, have a glance on outline. It contains the topic which I am going to brief. Now, let's begin with an abstract. I implemented a malicious application detection named as Android detection. To describe the behavior of a system, I use three combinations: system function, sensitive permission, and sensitive application. Now, moving on to the introduction part. As we know that nowadays humans are depending on various technologies and devices. These increase the growth of software and also the growth of smartphones. Due to this, some intruders are creating malicious application as a tool to steal or to damage a data. My project is based on cybersecurity. Cybersecurity has essential part of our life as crime over the internet increases rapidly. Here I am using machine learning to identify the malicious software that might harm our devices. Let's have a look on objective. The aim of a project to improve the permission cycle for detecting the malicious application on Android devices. Let's have a look on existing system. In existing system, non-machine learning way of detecting the malicious application is totally based on characteristic, properties and behavior of a system. But this technique is not efficient because hackers are being more innovative. They are using automation bots and artificial intelligence to breach and to damage a data. So, to stop the hackers, we are using the same technique. However, previous system that we had were not using any adapter technologies. So those systems were vulnerable. AI is the ability of a computer program or a machine to think and learn. It is also a field of study which tries to make computers smart. They work on their own without being encoded with commands. It has certain drawbacks. Let's focus on it. Traditional intruder detection are not sufficient to tackle the hacker. Non-machine learning is not reliable. It covers only 30 permission out of 300 applications. Now next, it is a proposed system. Let's have a brief glance on it. Here we are using artificial intelligence based machine learning to understand the pattern using network and identify malicious software. I implemented a SIGBIT, that is significant permission identification. It improves the permission of application and compare the training dataset and trained dataset with the help of machine learning algorithm such as SVM and decision tree. Support vector machine is a supervised algorithm which can be used for both classification or regression challenges. The subclassification is frontier, which best segregates the two classes hyperplane and lane. The advantages of a proposed system are: it has better intrusion detection, better malware detection. Machine learning is also allowing business today to operate with better efficiency and accuracy.
Let us turn to
It also
its
improves the runtime
advantages.
performance. The diagram appeared on the screen is a system architecture. Here we can see two databases. The one is malicious, which contain harmful file. The another one is a binning app data which have been affected by malicious. Next, the process started checking the malicious file with a binning app. What application affected by what file is known as data pre-processing. After the pre-processing of the data, next is sent it to data pruning. Pruning is a technique in machine learning and search algorithm that reduces the size of decision tree by removing sections of the tree. Pruning reduces the complexity of the final classifier. The next comes is building detection system. It is a method to detect suspicious activity divided into the system uses machine learning to create a model simulating regular activity and then compares new behavior with existing model. Then the outcomes we find as malware detection. Let's have a look on data flow diagram which shows the working of software. Schematic diagram of Android detection system. By seeing this diagram, we can clearly state the working of software. As the process started, it checked the function of the data. Then its work on monitoring on it. Further, it combined the data and record the behavior. The record data is then split into two. First one is app layer, which is an accessing point where the user interacted with the system, and the second is log analysis, where the conversion of a data is occur with eigenvector, which is nothing but decision tree of training set and training completion classifier. Analyzing system functions and how your data is get affected by particular file is comes under malicious behavior. The next topic is interception of behavior code. Target function. It is a function used to target a process. Ptrace is a process trace following the process. Here we are tracing the target function. Hook function. It is used to joining the function. Nmap. It navigates the process and trace it to create a map. Shellcode. It is used to open the code. The next come DL open. DL is a dynamic loading. It is used to open the code and start the function. DL sim. It is a symbol of dynamic load. The next monitor loading. The ELF means files to check. It persistently check for malicious file and give the outcomes of malware on your Android devices. Malicious code is a term used to describe any code in any part of a software system or a script that is intended to cause undesired effects, security breaches, or damage to a system. Malicious code is an application security threat that cannot be efficiently controlled by conventional antivirus. These code include computer viruses, worm, Trojan horses, logic bomb, spyware, and backdoor program. Other types of malicious code are able to spread and replicate by themselves and are able to propagate from computer to computer across a network. Use of non-machine learning platform is not efficient and also not reliable. The intruder can easily hack the data and damage it. And those applications and a system are vulnerable. Machine learning is a platform which deals with complicated choices. It builds the prediction model, and when the new data point comes in, it can easily project it for it. More the data, better the model, higher will be the accuracy. Let's turn to the execution part. The graph shows the malware count as an output. Here we are balancing the malware so that it improves the runtime performance as well as permission cycle. The next graph shows the permission cycle and counting the malicious data on your Android devices. Moving to the last figure. This figure shows the prediction and actual harm caused to your system or application. This is done by using malicious data and binning app, which are your trained data and training data set. The line on the right shows the actual outcome of your project. The prediction and the actual data is separated by zeros and ones. Now let's have a final look on conclusion part. Our project can identify with moderate success applications that poses a potential threat based on the permission that they have been requested. Our application can scan the applications on a phone at any time and alert the user to do so when app update occur. This project is solely focused on cybersecurity to detect malicious file or a software using machine learning on Android devices. And that's the end of my presentation. Thank you everyone.